Hello, everyone. Let us start the session. Apologies for a little delay. Let me share my screen. So this is a continuation session for what we have seen in the demo. So the demo, I'm not sure how many of you guys have attended, but in the demo, what we were looking at, we were understanding the concept of generative AI. I'll kind of take a quick walkthrough on what we discussed, and then we'll continue further on the topic. So generative AI is for creating something. So you can create text, images, and videos. So you'll have applications where you are interacting with generative AI. So these applications can be like ChatGPT or Gemini or any other internal chatbots, which will be using an LLM in the backend. LLM is the model, which is called as a large language model, because it is trained on large volumes of data and the nature of content is pertaining to any language. And the final outcome is the executable, which is a model. So that's called as an LLM. So LLM will be invoked from the applications. And those LLMs are nothing but it can be uh, open source LLM and closed source LLM. So if you know, the familiar ones are the ChatGPT has a LLM called as GPT-5. Similarly, Google has an LLM, Gemini 2.5 Pro, and so on. So we have both closed source and open source LLMs. The closed source LLMs are also called as frontier models, like GPT-4, GPT-5, GPT-5 Mini. And from Google, we have Gemini 2.5 Pro, Gemini 2.5 Flash. And recently, they released the Google Nano Banana, which is nothing but a Gemini 2.5 Flash image model. It's a very powerful model for creating a lot of images. Uh, we are seeing this kind of models getting released every other month. And imagine like if Gemini is releasing one model, next month OpenAI releasing even better model. Anthropic releases the Claude. Now the Claude 5 version is getting released, I guess. So Anthropic also is another company which is having these suite of models like Claude, Claude Sonnet, Claude Haiku. These are the different models which are available. Likewise, we also have open source models. We don't have to spend money every time on closed source models, but there are open source models available. The version from OpenAI is called as GPT OSS. We saw the Olama library where we saw all those model names. Similarly, we saw Gemma 3 model, DeepSeek, Qwen, and Llama. These are the different models which are available. So this is what we discussed about the course, but let us get into the code example which I showed. So this is the code example we saw, where what we were doing is we were trying to utilize the library called as Olama, and with Olama uh, we are able to create a local my own chatbot, and that chatbot can help to answer any questions. It will be like a replica of our chat GPT. So that's what we have seen. So let me quickly run that again, and we will continue further on building on top of what we have seen. So for somebody who have not attended this demo, it will be like a refresher. No, it will be like a information. And for somebody who have already seen this demo, it will be like a quick refresher. So if you are not understanding the code, don't worry, because throughout the course, we'll be getting into more details about what these libraries are, why are we using, and how are we using, and so on. So we will be using three libraries here. We are using the IPython display library for displaying my output. Then we will be using the Olama library for invoking the model, invoking the chat functions of the model so that I can call these applications. And the third one, you will use the Gradio library, which is used for creating a very small, sleek UI. I'll import these libraries. We will use the Gemma 3 model. Previously, I asked a question like, show me a recipe for biryani. Probably we'll change the question today. We will ask something else. It's not audible. Can you, am I not audible, guys? If you guys are hearing me, can you just say that I'm
Yeah, you
audible?
are audible.
Somehow Praveen is not able to hear others hear me. Just a second, huh? Wait. So what I'm discussing is we will be using the Gemma 3 1 billion parameter model. Now, I'll show you like what all models are available on my local. I can download a lot of models. To understand what are the models available, I can just say Ollama list, I guess. So when you do an Ollama list, it will show me all the models which are available in my local machine. So some models are heavy. As you see, there are like Llama 3.1, it's 4.7 GB size. 3.2 latest model is around 2 GB. 1 billion parameter is 1.3. And the Qwen models have also downloaded this Alibaba models. Qwen models, 1.7 billion parameter is around 1.4 GB. See, some models are good in some perspectives, some models are good in some other perspectives. So we need to play with them to see how these models behave. Uh, some are good in coding, some are good in reasoning, right? It can, you give any riddle and it will be able to reason it properly and can give you a correct answer. So some are good in some perspective and some are good in some other perspective. Just need to play with them to understand which are better. The ones which are now using is the Gemma 3 model. This is the one we used, Gemma 3 1 billion parameter, but you see that there are other ones available. Here I'm also pointing it to the Gemma 3 1 billion parameter model. Now instead of asking to cook biryani again, let us ask it to plan for a trip. So we understood that there are two prompts, important ones, the system prompt and the user prompt. System prompt sets the tone of the call. It says like what is the call about, what we are going to do, what are the rules and regulations, if there are any instructions for the model to behave, what are those instructions? All those things are laid down in the system prompt. Here I'm just saying that you are a helpful AI assistant, but I can also say that you are a helpful AI assistant which create travel plans. And then it creates a nice travel plans. You will consider the budget, you will consider the location, you will identify the proper places, you'll try to give itinerary with respect to travel. You'll also provide information about hotels, vacations, and stays, activities to do. So all those things I can write it in the system prompt. Now you're giving it a role. There are different types of prompting techniques. One important prompting technique is called as role prompting. Role prompting in sense you try to tell the model what is the role it is going to play. You will say that you are an expert travel planner. So that is the way in which you are trying to define the role. And then you'll also give like what as a travel planner you are capable of doing. All those instructions, all those things will be listed down in a system prompt. We will see more examples of the system prompt, but for now, you're just saying that you are a helpful AI assistant and I would like to travel to US. create a nice travel plan for a duration of 2 weeks. Make sure I visit all the popular places of US. That's what I'm saying. And this is the way in which the call happens. You will call the Ollama chat function. You will pass the model and the messages. This format is called as an OpenAI format. It's a standardized format across different models. So when there are plethora of models which are coming up, it and everybody using their own way of invocation, it becomes very difficult for somebody is doing cross-model collaboration, right? Imagine I want to use an OpenAI model, but again, I want to use, say, Gemini model, or maybe use Anthropic model, or use an open source model. I need to have some kind of a standard in which I can pass information to these models. If you standardize that kind of message passing, it becomes very easy so that I can just flip the models and everything else in my code will stay the same. So for that, there is some standardization required, and OpenAI came up with the standardization for invoking the models, for passing the information to the models, and so on. So this is that. So I can run this function, and what this will do is it is calling the Ollama chat function, passing the Gemma 3 model with the system prompt and the user prompt. User prompt is that I wish to travel to US, create a nice travel plan for a duration of 2 weeks, and it will make sure that I visit all the popular places. So once the information comes as a response, within the response, there is something called as message. And within that, there is something called as content. That is where our output is. And then output comes as a markdown script. Markdown script, we'll see that it is like, you could see that this is bolded. And it is nicely giving bullet points, sub bullet points, and all that stuff. As you see, this is a markdown script. So that's the reason the output by default, it is displayed as a markdown script. And when you say wrap it within the markdown function, it will respond in a markdown script. Now it is giving us a nice blend of 14-day trip, New York City 3 days, then Washington DC 3 days, then South Carolina. It is taking to South Carolina. Not sure why. It's taking to Nashville, Tennessee. It's getting into the Central America, and there you go. Then after that, it just shipped us to West Coast. Anyway, so it missed a couple of places. Probably I would have allowed to go to Florida, maybe places like maybe Miami, Key West. So those places I wish it could have provided, but anyway, right. So as you're seeing that it is providing all the details, and it is also providing the details of the flights and accommodations and all that stuff. It is trying to give us an estimate about how much we would spend. So let me quickly go through instead of wrapping it as a message, so I will use this Gradio interface. We have already seen the Gradio interface once. So the Gradio interface, what it does is it will call a function called as message GPT, which is nothing but a wrapper function of this call. So the same call, we are wrapped it within message GPT. Whatever we are sending as a question in the message GPT, that will be sent to my Ollama Chats user prompt, and it will go as an input, and whatever is coming as an output, that is what we are going to see. So I have provided this code as a Gradio interface. You guys are familiar with Gradio interface, right? We saw that in the past. If you are not familiar, just say no, then will explain a little bit about this. The Gradio interface. Okay, no problem. So what we are looking at this code is there is one library called as Gradio. As a shortcut, we are saying gr.interface. In this function, we will pass a function name. The function name is message GPT. And what is this message GPT doing? The same function which we invoked, it is wrapping it as an input function. It will take some input, And that same input, instead of having like a hard-coded one, now we are taking a dynamic input from the input of this message GPT, and that you will pass it to your Olama chat function call. And whatever is returning, that will be returned in the response of the message GPT. So message GPT as a function will have an input and output. That input and output is mapped in the Gridio interface. You were saying the function what we are using is the message GPT, and it will have an input and output. Input is a text box. Whatever you give as an input will be a text box. Whatever is coming as an output from the message GPT will be mapped to the output. Are you getting it? This is the code. Okay, so you say like, okay, this code is good, but what is it doing? If I go and click it, what it does is it opens up a website like this. It gives us two boxes, one input and one for output. I can write anything in this input. Now, what is this? So we've created an input for uh, message GPT. Now I can treat this like I treat this like a chatbot. I can ask what is the capital of, let's say, and then there you go. It is saying the capital of USA is Washington, D.C. I can ask any other question. If you have any questions, please put that in the chat window. I'll try it out if it is going to respond. Please feel free to recommend any questions. I can use that rather than me coming up with some superfluous questions. So now what we are understanding here is within one line of code, a small line of code, we are able to create a website, and it is able to invoke messages. So whatever is the input coming in the messages, for example, now I asked what is the capital of USA. That is the input question. It goes to the message GPT. From message GPT, it is coming inside of the prompt. That is going as the user prompt, and it is calling the Olama chat function. And whatever is the response is what we are getting as an output. And that response is the capital of USA is Washington, D.C. It is a fascinating city with a lot of history. Do you have any other questions? I can help, right? So it's basically responding, and that will be responded in the output. Got it? Any questions on this, whatever we are looking at it? Clear, right? So there is one more variant. The variant is, if I ask some bigger questions, for example, I say, what is a transformer model in LLMs? Something, if I ask some technical question, what is a transformer model in LLM? Then on the right side, it is taking some time. As you see, it takes like 4 seconds, 5 seconds, 6 seconds now, 7 seconds, 8 seconds. So it is taking some time for me to get back with the answer. Of course, it will get back with the answer, but it is taking some time. After, say, like 10, 12, 15 seconds, I got this answer. In simple terms, a transformer is likely a really smart, flexible pattern recognition system that can understand and generate text by paying attention to the relationship between all the words in the sequence. Very nicely explained, right? In a simple terms, it is explaining what is a transformer, what is it doing. Internally, we'll understand more details of the transformer architecture and all that stuff. But if you know, the transformer is nothing but is one of the model which is behind the generative AI, right? So if you say GPT, the T is the transformer, generative pre-trained transformer. GPT means generative pre-trained transformer. It's one of the algorithm which is behind the LLMs and the one which is helping us to understand the context, understand the meanings between the context, and then providing an output. But what we saw is it is taking some time. So instead of using the message GPT, I'll change the function to a stream GPT. Stream GPT, what it does is it will actually have a stream variable. Stream is equals to true. What this will do is instead of us waiting for a few minutes, what we'll do is we will give instantaneous result. So by when we are activating the stream option, it will instantaneously give us the result. So result comes in chunks. One chunk at a time, we get the result, and we will iterate through all the chunks, and then you yield the chunk. You yield the result. So for chunk in response, you iterate through all the chunks, and whenever you get the result, that you will yield as an output. So when you do this, what happens is you will get the result in a quick fashion. So let us see how it works. So the same thing, instead of message GPT, we are using the stream GPT. So I'll use the other link. This is the link which is publicly available. I will paste it on your chat and I request you guys to check if you are able to check the link. Now I can ask the same question. What is a transformer in LLM? So I'm asking the same question. On the right side, if you see, instantaneously it is responding in the Markdown script. Of course, the answer is a little changed, but as you see, it is responding with the answer. Now, I want you guys to click on the link which I pasted in the chat window and see if you guys are able to see that link. I'm sure everyone will be able to see it. If you are able to see it, can you also ask any question and then check if you are able to get the answer also. And let me know if it is taking a lot of time, because generally if everyone is bombarding questions, it will take some time, but should be similar to what I am seeing. Now I can ask another questions also. Can you write a Python program for adding two numbers? I'm asking some simple questions. So let us see if it is able to give me a Python code. Now it is taking a little time. The reason is because I hope you guys are bombarding it. There you go. It is writing the response. Add two numbers. It is giving us a very nice description. So did you guys try any question, and can you guys let me know if it responded with the answer? Did you guys try it out? Anything? It responded. Good. So we spent like what 10-15 minutes, and I was able to quickly create an application. Now this is my own chatbot, right? So we were able to create our own chatbot, and it is responding with our own answers, right? So that's what it is capable of doing. Now I will now add a little layer to it. So we are using Gamma 3 model in the above. So I want to have an ability to select models. Maybe I imagine I have like 2 or 3 models. Now I want to select Gamma model, I want to select Llama model, maybe DeepSeek model and Qwen model, and I want to compare between the models. Maybe I want to use one model for coding and other model for general the purpose answers. So for that, let us create a small function in which we are also expecting not only the prompt, but we are also expecting the model, what model we are using. So if at all we are saying Llama, then it points to the Llama 3 1 billion parameter model. I showed you, right? I already have all these models. Llama 3 1 billion parameter is also available. DeepSeek model is also available. Qwen model is also available. So what I'm doing is I am saying that if at all we select Llama, then internally we will point it to the Llama 3 3.21 billion parameter model. If I'm pointing to Gamma, then it points to the Gamma 3 1 billion parameter model. Okay. The other code is same, just I am saying like which model will be selected based on the input which is provided. All right. So that I'm saying as stream model, the stream model is updated with this input. Now the Gradio interface code will also get changed. So in the inputs, we will have two things. One is the text box, which is the question which I'm asking. And then second one, we'll also have a drop down. Drop down will have an option, Llama or Gemma. I can select one of them and that goes as an input to my model. We will have two things as an input, right? First one is the prompt, which is the question which I'm asking. Second one is the model which I would like to act on it, right? So that's the two things which will go as an input. So here you are saying text box as an input, and the Gradio dot drop down, which is like a drop down where you'll have two options, Llama and Gemma, and I can select one of the option for invoking my model. So once I run it, I'll show it in the local itself. This is how it looks like. There you go. I have a space I can write my question, and I also have a drop down. I can have a Llama and Gemma. So first I'll ask Llama. So Llama I have not invoked, so it will take some time for the first time invocation. I'll say, who are you? I'm asking Llama, who are you? So it will scratch its head and come back with an answer. On the right side, you should see that I am an artificial intelligence model known as Llama. Llama stands for Large Language Model Meta AI. Llama is released from Meta AI. So it is an open source version of uh, the large language model from Meta. Now we'll keep the question same and let us ask Gamma, who are you? Now the Gamma says the Gamma large language model from the Gamma team by Google DeepMind. Got it? So you're getting answers from both of them. Can I ask any other question? Can you just give me one question, guys? I'll ask it both of these models. Anything which you might have tried previously, you can just paste it in the chat window. I'll ask the same question. You were typing, you were chatting. Uh, any one question which you would like to ask? Or else let me only try it. Now I'll ask some interesting one. I'll ask who are the winners of the latest Cricket Women's World Cup? Okay. Who are the winners? Latest Women's Cup. Now, this is a tricky one because both these models are old models. Both of them have no idea about the Women's Cricket World Cup. Now, let us see what Gamma will tell and what Llama will tell. Okay, so let us see. Okay, so now it is giving me information. 2023 Women's Cricket World Cup winners. India won the tournament. Now you guys have to tell whether this is correct or wrong, right? And Australia is in second place. That's what it is saying. 2023, World Cup. Uh, this is what it is. I don't think we have won in 2023. But correct me if I'm wrong. But this information doesn't seems to be correct. Let me see. Yeah, ICC Women's 2023 World Cup winners are Australia, not India. So here it is. What is this feature? This feature is called as hallucination. Hallucination means it will give what Lama will tell. See, there you go. It is saying, I'm sorry, but I cannot verify the winners of the Women's Cricket World Cup. Right? So as you see, this is the now we saw both the models, the Gamma model and the Llama model. Llama model is not hallucinating. At least it is saying that, boss, I don't know the information, so I can't give an answer. This is much better for us rather than somebody hallucinating. As you saw, the other model hallucinated. Hallucination means just making up things which are not there, right? So which is not correct. It gives a wrong answer. So, okay, there is a question that what if we ask a model which is an unknown answer to us, but it didn't give the right answer? There is a case, right? As I said, uh, yeah, for example, I don't know, like there can be any question where we don't know the answer. For example, uh, uh, any fact or any information which is very, very unknown, like what is the depth of some Marina Bay or something like that. I don't have a clue. So let me ask this. What is the depth of the West Ocean? Something like that. Okay. Let me ask Gemma. It is good in hallucinating. Its depth is approximately, just remember, 10,000 meters or 35,000 deep. It is called as Challenger Deep. Okay, it is in the Mariana Trench. That's what I was forgot the name, so I just gave. So Challenger Deep, it is around 35,876 feet or 10,000 chiller. Let us ask Lama. Challenger Deep, Mariana Trench. All right. It is also giving us the same answer. So both of them are trained with the right data and it is giving the same answer. But I don't know whether this is the correct answer or not. But there is a chance that the models can hallucinate. When the models hallucinate, they give wrong answers. To overcome this problem, there are multiple techniques. So we do a technique called as RAG, Retrieval Augmented Generation. We do create agents which also verify with real-time data. So you can invoke a tool which can give us the real-time data, and then that content will be augmented with the answer of the LLM, and you will give us a new information. So now we have something called as agents. We will cover in our course called as agentic AI. In that we can create like how I can retrieve latest information, maybe latest web information, latest web reports. It can be historical information. It can connect to our databases and get the database related information. All those things can be done. And so that whatever we are trying to give as an output, it is it is basically is more accurate. So the sources to the RAG can be Google data. Yeah, you are like you do a web search. So there are SERP APIs which will help us to do web search. Google SERP APIs are there which will help us to do like as if like I am doing a Google search. These APIs will do the same search for us and then provide the data to the RAG, and the RAG will update information and provide us more meaningful output. Got it? Any questions on what we discussed so far? Are you guys following? If yes, can you put a thumbs up or something? There's a question like, so basically models are retrieving from Google most of the time, and can we believe Google is providing up to date? But that we can't because information, the way information is provided, that is the one which is becoming the basis for creating answers. So if the information itself is wrong, the base data itself is wrong, or the source provider itself is providing wrong information, then there is no way in which the LLMs can give correct answer. We
So,
will do something called as LLM as judge. LLM as judge is a mechanism to evaluate the correctness of the response. So you'll ask two LLMs like the way we did right now, right? I asked a Llama model and I also asked the Gamma model, right? Now I want to identify this depth, the correctness of the answer. So I'll ask for two models, and for two models, they should give me the same information, the same name of the place, Challenger Deep, and also approximately the feet information, also the depth information. So both of them should be closer, similar. Then you could get. But if,
hey Sitaram, the question is like if both LLMs are pointed to the wrong information source. Like I
they,
had
they,
some Reddit post and
yeah.
someone inappropriately or some no, no, some different answers are being
Yes.
updated. So is there any algorithms or something that way it will decide like based on like I fetch for suppose if I fetch like 10 to 20 sources of information to the LLMs. So and it makes a decision that I'm pretty much confident to fetch this data or this data is not eligible or something that way. Or it's just sources depends on the how much of quality of sources we are feeding.
Yeah. So first thing first is it is as intelligent as the data it is having, correct? So
Mm-hmm.
wherever it is getting the data, we will say that okay, fetch the data from these places. So it can get it from
Mm-hmm.
these places. We have to
Mm-hmm.
vet it and then say, okay, this is the place where this is the place which I will believe as a response, and then it can get it. Now, no, it can be wrong. Probably I'm pointing to Reddit and Reddit is having some false information and it will give false output also. There is no way I can correct that. That's one challenge because, if there are like unknown answers, I don't know the answer, I
Means it's like I for suppose I give like one official document and I was troubleshooting some website or some Python code or some code, and for reference of that I am mentioning like some Reddit posts, some YouTube posts, and some Wikipedia posts and everything. And is there any way I can tell to ChatGPT or OpenAI? I mean, so some LLM telling that uh, get the sources fetched and based on some score or some confidence levels or something that way, is there any algorithm for that type of things so that we can be more confident that it is intelligently doing all the task and everything, troubleshooting and everything, instead of hallucinating, which is in the case.
I think Sitaram left and rejoined
Okay.
Sally.
Yeah, okay, sure.
Um, Blip in the internet.
Mhm.
Yeah. So what I was saying was there are techniques in which we can compare multiple models. That's what we call it as LLM as judge. So I can use the technique. We can compare a couple of models, and then from them probably do a voting like which one is better, and then can get the final answer.
So not a
But the
single
challenge
element do this. Sorry to
single
cut you off.
LLM
Yeah.
answer, right? So it's the single answer you're getting, correct?
So the thing is like ChatGPT or multiple things are releasing agentic AI means the agents running as autonomous, right? So how I can be confidently telling that if we are unable to get that probability or confidence levels on the data or the it fetched, so how we can trust and give the automation process to the agents? That's what I'm curious.
Yeah. So very valid point. I think even research is working in the same direction to see how we can improve the quality of responses, where we need to put more guardrails like checks and balances. If I'm using automation for internal information, then I know
Mm-hmm.
like which LLM is called, what response. So that's where the testing process has to increase. Like, what should be my question and what should be the answer for that question, and if that agent is correctly doing it or not. So there are multiple techniques which are being followed right now to check the
Okay.
correctness of the answers over a large volume of questions. But even if I do all these things, we are in a very, very preliminary state, right? That's the reason people are not going forward doing a
Mm-hmm.
complete automation. So we have a human in the loop, which basically checks the response, whatever the LLM has provided, if that is acceptable. And then
Mm-hmm.
based on that, we will try to give as a outcome to the customer. So like human in the loop is currently being adopted, but eventually, based on how good the models have become and so on, they will try to get into that autonomous way of doing things. But it has to be very deterministic. Deterministic in sense the answer has to be exactly same. Currently, the way in which we are trying to do, they are in a probabilistic state where this multiple information sources are being used, and one of them is being used as a response. We have some knobs which we can tweak. For example, there is a parameter called as temperature, which we
Mm-hmm.
can tweak to make it more deterministic or probabilistic. So if you want the answer to be exactly similar, then you will tweak the temperature parameter to keep it low. So that will help us to make better outcomes, right? So the question is valid, but the answer is yet not discovered because it's a moving target, right? So we are inching towards getting such kind of an application, but there is no way it's as good as the information we are feeding, right? So there is no way for us to say whether it is correct or not.
Okay, got it. Yeah.
Got it. Any other question? I'll spend a few more minutes. If you have any other questions, we can discuss. I'll just quickly flash my screen to discuss about the structure of the course. So we'll be learning starting with Python for AI. So we'll be doing basics of Python in the next few weeks. Then we will be covering classical machine learning, where we'll understand the classical machine learning models, supervised, unsupervised models, and so on. And that will take around 15 to 20 days. Once we complete the classical machine learning, then we'll get into generative AI, where we will cover all these topics in depth. We'll go to a deeper level of coding and we'll understand all those topics. And once we complete the generative AI, we will get into the agentic AI concepts. How do you create agents, autonomous agents, human in the loop agents, so that we can construct these agents both with code and no code. There are techniques like different frameworks are there which will help us to write code for creating these agents. And there are some frameworks which are low code, no code, which will help us to create simple agents without any code. Once we complete all those things, we'll get into the ML ops and LLM ops. These are the techniques in which we help to deploy the models into production. ML ops helps us to deploy the models, machine learning models into production, and LLM ops helps us to deploy generative AI applications, agentic AI applications into production. And last but not the least, we'll also cover cloud computing involving AWS, GCP, or Azure, where we will understand that if at all I want to deploy ML models or generative AI models in AWS, how do I do it? In cloud, how do I do it? All those things will take us around 2.5 months of time. Our classes will happen 6 days a week. 1 hour will be the duration. 45 minutes will be the course content with 10 to 15 minutes of question answer session. So you give and take around 45 minutes we'll be spending on the class, and then around 10 minutes will be for the question answers. The class will happen at 7 a.m. IST as today's time. So it started at 7 a.m. and session will end at 8 a.m. 5 hours a week, I will recommend you guys to spend additionally, apart from the regular learning you're doing. You have to spend at least like 5 hours outside of your learning window, maybe during your work or maybe on the weekends. You can spend a little time on understanding the concepts. So I'll be talking about all the concepts. We'll be doing more hands-on. Maybe you could practice those codes. Maybe you can go do Googling and understand different other functions which can help us to do the same type of coding, different frameworks which will help us to do the same type of work. So you need to do a little practice on your own. So for that, I recommend 5 hours a week. All the materials, codes, and videos will be uploaded in the drive for you guys to access, and I think you'll get a lifetime access for all those materials. So there's a question that will ML ops diminish once the agentic ops is into the full blown? Yes, eventually, but agentic AI is more into generative nature of it. Machine learning is still the most widely used one for businesses to generate revenue, right? So for example, the models which are already currently working for, say, like fraud prediction, or loan detections, doing campaign management, employee nudges, all those things are machine learning models. They are the ones which are deployed into production. They are the ones which are giving revenue to the company. Agentic AI applications are still in that hype cycle mode where we are thinking that, okay, agents will do all this work, but eventually it has not materialized yet. And we have not kind of ruled out the options of using those things. So LLM ops is the one which is used for deploying generative AI applications into production. That's what it will be. ML ops will still stay the same because we need to train the models. We need to do deployment of the models. We need to create online and batch-based deployments. So all those things will still stay the same. So at the current moment, understanding generative AI, agentic AI, LLM ops is more beneficial. Yes, that is correct. That is correct. But we are still trying to reap the benefit of it. So you can't forget the the ML ops. Got it? All right then. Thank you very much, and we'll come back tomorrow, same time, 7 o'clock. We will cover some more things. We'll have a few more students who will be joining us from tomorrow, and then we'll continue our course. All right. Take care. Have a nice day. Talk to you tomorrow. Bye.